Hello and welcome to a brand new edition of DevOps World. In this edition, we are going to look at a very interesting problem with regards to Karpenter, right? So if you have not followed the episode on Karpenter, I will leave the link below. So basically Karpenter is a kind of a controller that you deploy onto your Kubernetes to kind of, auto scale, right? Auto scale based on the optimal compute or memory requirements for the unschedulable parts, right? So there is, however, one problem that happens if you are running batch jobs on your Kubernetes cluster, and Karpenter is trying to consolidate your jobs. Now imagine a scenario, right? You have, let's say, two jobs, Kubernetes jobs being executed on a particular node. So let's imagine that there's a 2-minute job and there is a 5-minute job, right? Obviously the 2-minute job is going to finish first, and then the 5-minute job is still going on. So what happens during that time is that Kubernetes is going to realize, or rather Karpenter is going to realize that, hey, you know what, the node is being underutilized, right? So it'll try to consolidate, right? So what it'll try to do is it will disrupt the 5-minute batch job, and it'll try to place it onto a node that is basically kind of, more optimal for its usage, because the 2-minute job has finished executing and there is no need for whatever the compute was allocated for that 2-minute job. So what happens is that Karpenter is going to disrupt the 5-minute job, and it's trying to go and schedule it onto a different node, which is probably kind of a more a smaller node with a limited configuration, just optimal enough to execute the 5-minute job, right? Now the problem with that is that with batch jobs, if they can't kind of tolerate disruption, right? So they will have to start over again after rescheduling to a new node, right? So we want to avoid something like that with Karpenter, right? So in this episode, we are going to look at the strategies we can use to make sure that the consolidation is kind of not happening when there is a 5-minute job or a 2-minute job finished executing and a 5-minute job still there. So we want to block consolidation in terms of when we are having batch jobs. The reason is because we want to make sure that the batch jobs, once they are started, they execute to its completion, and then only consolidation takes place, right? So this is a kind of blueprint. You can kind of use it when you want to run batch jobs and you want to make sure that they don't get disrupted as a result of kind of varying times in which these batch jobs complete. So let's get started. There's going to be a demo. We will actually deploy these jobs and we'll see how the disruption happens first. And then we'll actually make some changes so that the disruption does not happen. And then we'll see how it works out, right? So let's get started. So let's look at the scenario here. So these are the unschedulable parts. So now let's assume this is a 2-minute job. And this is also and this is a 5-minute job, and this is just a pod. Okay, so Karpenter sees that we have these unschedulable pods. So what does Karpenter do, right? As a response, it tries to create a node that will fit these unschedulable pods, and then all these workloads are being executed on this particular node. Now what happens is that after 2 minutes, this particular job is finished. There's a 2-minute batch job. Now that means that the 7 CPU requirement is no longer needed on this node. So this node is being underutilized, because this requires a 2 virtual CPU, and this particular pod requires 2 virtual CPUs. So now what Karpenter does is it realizes, hey, you know what, this particular node is being underutilized. So now please remember that this is a batch job, okay? And this is a 5-minute batch job. Now what happens, right? Karpenter is going to start a new node and it's going to disrupt these two pods. It's going to disrupt them and move them on to this particular node. Okay, so it'll launch a new node and it will move these two into this particular new node, and it will kill this node. So what happens here, right? This batch job got disrupted and it'll have to restart all over again, right? So this is something we would want to avoid, because it will be better for this job to execute even though the node itself is being underutilized. We prefer the job to actually finish from start to finish without disruption, right? So in this in the subsequent demo, you're going to see how you can actually make sure that this disruption does not happen and the job will continue to execute on the bigger node, but only after this job gets executed will the disruption happen, and this particular pod will be moved on to a new node, right? So let's get started with a demo and we can see how this works. So here we have a cluster. So this is the cluster over here. You can see the cluster, and let's say we'll look at the nodes in this cluster. This is a 2-node cluster, and we'll look at the default namespace. So here we are going to deploy 3 jobs. Let's look at the jobs. So in this case, let's look at we'll look at workloads evicted. So in this thing, we are going to do a deployment of Nginx. So this is requesting about 2 CPUs. Then we are going to basically do a 2-minute batch job that's requesting around 7 CPU, and then we'll deploy a 5-minute batch job that's going to kind of request a 2 CPU. So the idea is basically we kind of create 3 jobs or deploy 3 entities. The 2-minute job is requesting the maximum resources, which is basically 7 CPU. So what we are going to see is that the 2-minute job gets finished first, and then we'll see what consolidation happens, right? So let's get started. Okay, so we deployed here. We deployed a 2-minute job, a 5-minute job, and the Nginx server over here. So as you can see, Karpenter realizes that there are unschedulable pods over here, and it tries to get you a new node. So it's getting a C5 4x large node, and once the node is ready, Karpenter will schedule these pods onto that node. So it's just now ready. So let's see the pods getting scheduled. Yep, we just got the pods getting scheduled onto the node. So all of the pods are running. So the node is optimized, right? I mean, here you can see the usage over here. Now we have to just wait for the 2-minute job to finish. So let's look at the counter over here. So I'm going to pause a bit over here the recording to make sure that, or rather we can actually wait. It's just 2 minutes. So you can just focus on this job over here. So this counter. So as the 2-minute job, so I'll just try to explain what happens. As the 2-minute job gets executed and it's finished, the consolidation will happen over here. So you should see these 2 jobs getting disrupted, the 5-minute job and the Nginx pod getting disrupted and moving on to a new node. So we are about just I think a few more seconds left, so we can just wait and see what happens. So yeah, well, while in the meantime, if you have watched the video this far, just make sure to subscribe so that you can get notified whenever new videos are basically released. and spread and share the video with the friends if you like it. So let's say this job is still running, so it's almost going to finish now. So it's 2 minutes 19 seconds. So we gave about a few seconds for it to kind of get scheduled, so we'll just subtract that. So I think any minute, any second now, this guy should finish, the 2 minute job should finish. And once that's finished, you should see consolidation happen over here. Now consolidation, generally our setting for consolidation now, okay, so this got completed, but one thing that you have to remember is that we have given a consolidation setting wherein we say, you know what, let's look at our node pool, or rather workloads evicted. So okay, so now this is completed. So these two are still running on the main pod here, main node. I was going to show you something, but yeah, let's watch this first, and then I'll get that. Okay, so what I was looking for is a 1 minute consolidation window wherein we are asking for 1 minute time before consolidation happens. So that setting is in one of these settings here in one of those YAML files. I was going to show you that, but let's just see what happens here first, and then we want to witness the disruption. And once the disruption happens, then we can kind of look at the settings that we can kind of do to prevent the disruption, right? So the disruption will happen in about let's say a few minutes. Okay, you should see a new node coming up here. Okay, so Karpenter took 1 minute to realize that it's being underutilized, so it launched a new node. This node should be ready now, anytime. Once it is ready, these two will just be moved on to the other one, okay, to this guy. So let's see. Yeah, it should go out now, anytime. Yep, you see that? This is the disruption I was talking about, right? So this disruption, again, the 5 minute job and the Nginx pod both got scheduled onto the new node. This is a smaller node costing 38 cents a minute, and the other one was costing around 76 cents a minute. And it got a smaller node for us, and it's deleting the earlier node, right? So this is basically the consolidation that we want to avoid for this 5 minute job, right? So this got disrupted. Okay, so let's get started with the second part of the demo, in which we're going to make a small change. We're going to basically prevent the consolidation, right? In the last segment, we saw what happened when we did consolidation, wherein we saw disruption happening to the 5 minute job. So there was one setting I wanted to kind of show you, that is the this setting over here, wherein it says consolidate after 1 minute. So basically Karpenter is going to wait 1 minute before it realizes, hey, you know what, the node is underutilized. So it basically waits for a minute before it starts the consolidation process, right? So now let's look at a different setting wherein we are looking at workloads not evicted, and here we are looking at a specific setting here. So let's go back to this setting. So here it says will prevent disruption, do not disrupt, right? So both of the bad jobs have the do not disrupt annotation. So let's deploy and see what happens, right? Okay, so we deployed the Nginx server, the 2 minute job, and the 5 minute job. So as usual, the first is going to look for a bigger node to schedule all of these pods onto that node. So the 2-minute job, 5-minute job, and the nginx job. So it's shopping around for a node. So once it gets the right node, it will schedule each one of these, Kubernetes, jobs, these two jobs and this particular pod onto this node. So yeah, all three are scheduled now. So now the counter starts for the 2 minutes to expire. So what we have to look for is the 2 minute, right? So once this 2-minute job basically finishes, we should not see a disruption happen until the 5-minute job is also finished. So in this particular scenario, because we actually changed the annotation to not disrupt, so once the 2-minute job finishes, we still, even though the node is underutilized, you should see that the pod 5-minute job will still continue on that same node and it will not be disrupted, right? So I'll pause this video now here and wait for the disruption to happen and then restart it again. Okay, so we're back. So the disruption of the 2-minute job should happen anytime soon. So it's already past 2 minutes and we give some time. Yeah, the job finished. So now here you see the node is underutilized because this was a pretty heavy job. It was taking 7 CPUs, but as noted, right, the 5-minute job is not getting disrupted, right? We have to wait for 1 minute because we gave the disruption consolidate option for 1 minute. But even if it goes past that 1 minute, you should see that this particular node will still remain the same and it will not disrupt, right? So let's give it some more time. So it's 3 minutes. So let's check back around the 5-minute time frame. Okay, so we're back. The 5-minute job is still being executed on the bigger node. It didn't get disrupted as expected. So now it should finish anytime soon, and then we will see the consolidation happen, right? So 5 minutes, so we'll factor in about 30 to 40 seconds for the node time to launch. So it should, yeah, it did complete now. So now you count for 1 more minute from here for the consolidation to kick in. So now that we prevented the bad jobs, okay, so now this job is running, this is a pod. Now we should wait for around the 6:30 time frame, like 6 minutes and 30 seconds time frame, wherein I'm expecting the consolidation to happen. So this node will be discarded, a new node will be created, and this particular nginx pod is going to be scheduled onto that new node, right? So let's give it a few more seconds. And meanwhile, please, make sure to subscribe to the channel and like and share the video. So it's 6 minutes 30 seconds. So now we are around about the 1 minute consolidation window. So you should see the consolidation kick in at some point, right, in the next few seconds. So it should realize now that this node is completely underutilized, and it should move this pod onto a different node altogether. So we are waiting for that consolidation to kick in, and once that happens, you will see the nginx pod getting disrupted. So let's give it yes. So it did realize that the node is being underutilized, so it started a new node. And we are going to see that this pod is going to be disrupted and scheduled onto this particular node. So the node is not ready yet, about 30 seconds. Yeah, so give it some more time. Okay, the node is ready. So you should see disruption kick in, and the pod, yeah. So the part got moved on to this node, and the bigger node got deleted. So I hope you found this video to be useful. So we can see how we prevented the bad jobs from getting disrupted. So again, the key is this particular setting over here, wherein you basically have to make sure that you have this annotation in place to kind of prevent the disruption to happen. Do not disrupt to true. Okay. I hope you enjoyed this video. Please like and share. Thank you.